By now, you know that configuring static NAT or static PAT is pretty easy and straightforward. But what if we want a specific static NAT or static PAT statement to trigger only if a certain condition is met? Now, the condition typically comprises of a source and a destination IP address. For example, you want a specific static NAT statement to trigger when PC A is trying to talk to server B. For the rest of the traffic, you may want to trigger NAT overload for traffic going towards the internet for PC A. Now, this can well be achieved by leveraging conditional NAT with the user route maps. This is exactly what we will focus on in this lab with a real-world example. Hello and welcome. Today we will be discussing conditional NAT, and as the name specifies over here, it is based on a condition. Now, if you have seen the previous video, that was a NAT overload with dual ISPs in which we used route maps. So in conditional NAT, we basically use the route map, but with that, we also use a static NAT statement. So we are gonna look at a scenario that basically happened to me in my real life. Normally all the things I teach, normally they do happen with me one way or the other. But the thing was, I did not even know about the conditional NAT. This was the case, I had to leverage conditional NAT. I did not know the concept, but now I'm gonna give you that concept in this lab. Now, if you're watching this video on our website, you can find this lab in the materials section of this lesson. Now, just to give you an overview of what we have at our lab disposal, we have on the left side our office, which is the DN office, and we have a payment server, as you can see on the left side, and we have a switch, which is everything is in VLAN 1, so nothing is configured apart from the switchboard mode access on both the ports. And then we have our NAT router, as we always do in our NAT series. There's our NAT router. And then we had a special case or requirement that our payment server needed two banks connected to it so that it could actually accept their vouchers or something. No, truth be told, I did not know what the case was, that why the payment server was not using like payment gateways and stuff. But the condition was they're going to be terminating two IPsec VPNs from two different banks so that payment transactions could be made between them. Now, the banks actually had this condition that we are not going to entertain your IP address, which was 192.168.10.80. They said that, you know what, that IP address that you are using is obviously a private IP address, right? So RFE 1918, you know that. So anyone could use that IP address inside of their network, home, banks, whatever, and wherever they want. So they were like, we can't actually entertain that IP address because we are already using that IP address in our bank. And same with the bank 2 guys. So they also said that we're not going to help you with that. You have to do some kind of NATing on your side alongside IPsec tunnels so that whenever your server, which is a payment server, as you can see 192.168.10.80, talks to us, it comes from a specific IP address. Now, that was easily achievable for me for doing it with one bank. I just had to do a static NAT statement, and that was it. And everything was working fine. But then I realized when I had two banks coming into this NAT router with VPN terminations, I realized things got really ugly. And I did not understood how it's done. So I ran into this concept. Actually, one of the banks had this IT guy that basically helped me in understanding this concept. I did not know at the time, but it was called conditional NAT in the iOS or iOS XE devices. So I leveraged conditional NAT to accomplish this task of them asking me for a specific source IP address. Now, I kind of got deep into that story and I forgot to tell you about these payment services that these banks have. So they're like payment servers with which the bank own. Now, this topology obviously isn't gonna be like this. They're gonna have multiple firewalls inside of them because they're a bank, and so yeah, actually. This is now how they would really design it. And these two routers are from different banks, and they have VPN terminations. VPN terminations with me. Basically, they have two legacy side-to-side VPNs terminating on my 80.1.1.1.1, and on their perspective, it's 100.1.1.1 for bank 1 and 200.1.1.1 for bank 2. And we don't actually have payment servers. So what I did, actually, I configured telnet on these servers with a banner saying that there are bank server 1 and bank server 2. So this is how we're going to be testing. We're going to do some pings and some telnet packets going towards these servers and accessing them and seeing what our connection looks like with their perspective. So let's go ahead and jump into the lab. So the first thing that we decided with the bank was what IP address suits them, both of them. Obviously this IP address, which was, let me just write that down, 192.168.10.80, was not suiting them because they already had this IP address configured somewhere in their networks, both of them. So I had to ask them that, hey, can you just give me a private IP address that you aren't using in your environment and which is available, so that I can use that IP address and it doesn't actually does any harm to me as well, obviously. So we go ahead and decided, first of all, let me check if I have that IP address already configured, because whatever the IP address we decide, we have to take care of that in the IPsec tunnels as well. So I don't really want you to get too confused in this lab, because there's something called interesting traffic in legacy IPsec tunnels that we have. So that interesting traffic, that source of that would be that IP address that we decide on my side, and the other one would be theirs, which is 10.1.10.100 over here and 10.1.20.200 over here. So let me just check that real quick if I did any configurations regarding that. Crypto. Let me check real quick. I should have done a show IP access list. Okay, so I've got two. Okay. Show IP access list. This is the access list that they are referring. Both of them are obviously different because the sources might be the same from my side, but the destinations are different. So okay, so yeah, I basically decided this IP address to be the one that I will be using with my bank. So it was 172.16.1.100. So it was not class A, which was used over here, and it was not class C. So I basically decided to use this one, 172.16.100. Let me just duplicate this guy and put it here, and just for reference, 172.16 and 1.100. So this is gonna be my source IP address when I talk to these guys. Okay, when I talk to 10.1.10.100 and the 200 over here, so that will be my source IP address. They won't see this source IP address that I already have configured, which is a real IP address, by the way. So that is actually the first step that we decide. So we have our VPN configurations up to date according to that, on their side and on our side, because it takes a lot of time, because they have a lot of burden on them. So it takes them a lot of time to amend these kind of interesting traffic ACLs. So that takes time. So we're done with that. The first step was deciding the source IP address, which suits both the banks and myself, of course. Alright, well, moving on to step number 2. Create an ACL for conditional NAT and call it in a route map. Now, it's really easy. The condition that we are going to be using is something like this. Let me just duplicate this guy and put it right here. The condition is, it's very simple actually, the condition. The condition is whenever my payment server is trying to access, I'll say 10.1.10.100, that is one condition. And the other condition would be if it's trying to access, okay, that didn't really work out. Let me do an enter here and paste it there. Let's go back to here. 20.200. All right, these are the conditions. So I'll just duplicate that too. And sorry, I'm doing this on the fly. I should have done this beforehand. And things are really getting messy now. So I don't know what's happening, man. Oh my God. Oh, let me just copy this guy. I was just putting a heading over here that, hey, this is the conditions that we're going to be using. Conditions. So these are the conditions and they will be specified in an access list. So this is the first condition, right? So the traffic has to come from 192.168.10.80 going towards 10.1.10.100. Now, as this is a static NAT, you will see this condition actually works in both ways. So let's hop onto the router and configure this condition. First of all, 192.168.10.80. Configure terminal, IP access list. First of all, it's much better to see if any access lists have already been created. So we have two IP access lists created. So let's create an access list like IP access list extended, and I'll call it DNCON conditional ACL. So not too long. DN conditional ACL. So for the condition that we specified was if the payment server is talking to, first of all, permit IP. I'll use the host keyword because it is actually /32 wildcard mask, you would say, or a subnet mask, and the inverse of that would be 0.0.0.0. So host works the exactly same way. 192.168 10.80. Going to our host, that'll be 10.1.10.1.10.100. That's the first condition. What is the second condition? The source will be the same, but the destination IP address will be 20.200. So we're actually done with the configuring the conditional ACL. Now it's time for the route map. As the second step says, create an ACL for conditional NAT and call it in a route map. So there is no route map. You have to configure one. So route map, I'll say again, RM, conditional route map. So matching the access list, match IP address. Again, if you're not familiar with that, you can go back and see the route map lecture or the previous lecture on overload with dual ISPs. Okay, so the ACL, is this one. So calling it, that's it. No need for set statements. No need to apply it anywhere on an interface. You apply it in the NAT process. Now, speaking of NAT process, I think I have forgotten to actually, oh no, it's gonna take a little while now. So I forgot to actually configure the interfaces as inside or outside. So before I do the NAT statement, let's do that real quick. IP NAT inside, and it's gonna take few seconds to come back up. Actually, I don't know why this happens, because I have a lot of RAM in my server, but still it happens. If you guys know, you could just comment or email me what's up with it. So all right, okay, so where are we at? Okay, interface gig 0/1 configured one interface. Gig 0/1 is the second one. IP NAT outside, so that's the outside NAT zone, you could say. So now it's coming to the statement. So we have everything configured. Show IP NAT statistics. We have both the interfaces configured accurately. We have the ACLs. Show IP access list. Those are the VPN ACLs, and this is the one we created for matching. So now it's time to apply all those conditions into a NAT statement. So what we're going to be doing is just a simple static NAT, okay? You know how that works, first of all, okay? So what we're doing here is we're saying that whenever this IP address comes from the inside, you have to translate that IP address to this IP address, and that's pretty easy, right? A static NAT statement for that would be really piece of cake. So that would be IP NAT inside source static, and it's asking me for the inside local address, and that is 192.168.10.80, right? Pretty easy. And then we are going to translate it to 172.16.1.100. So that's going to be its translated IP address. So 172.16.1.100. Very easy, isn't it? It was really easy, but if I just press enter here, there is no real condition. So every time it basically communicates with anything, it's going to be translated to this IP address. But the problem with that is that server also needs internet access and other accesses that will be coming up in our environment. So we can't actually tie a single IP address with that, right? So what about the internet? We can't actually do a NAT of a private IP address to another private IP address and expect it to actually go out there on the internet. It would get dropped. So actually this doesn't really make sense at all. It's not scalable at all. So we actually use a route map condition that we created, and I forgot its name, so I'm gonna do show route map, and this was the route map name. So wait a second, I just hate it. Do term width 512. Yeah, okay. Now it should show up. The commands get eaten up because you don't have this terminal width command. Okay, IPNAT inside source static. This was the command. A route map. This was the condition that we were applying. So this is the condition, and we pressed enter here. Now what's gonna happen is, if the server over here tries to make a session to the other servers, it's gonna hit this NAT statement. So let's verify that. So let's do a ping to 10.1.10.100. This is the first IP address. Right, I go into this mode and say, okay, 10.1.10.100. Now I'm pretty sure it won't work. Oh no, it did work. Oh, that's great, because I was like, okay, I goofed something up in the VPN tunnels. It's gonna happen. It's gonna happen. Oh, it always happens. So let's go into the NAT router and see show IP NAT translations over here. So you can see we're doing a ping obviously right now. So this was the inside local IP address, and it was translated to 172.16.1.100, and this was their sorry, and this was their destination. So we weren't doing any destination NAT or anything. All right. Now the other one was 10.20.200. Fingers crossed. Let's see what happens. Come on, come on, come on. Don't let me down. Don't let me down. I think it has let me down for some reasons. I don't know what. Now, if you would bear with me, I would really want you to do a troubleshooting on this and see what's wrong. So show crypto IsoCampus. First of all, I'm going to be seeing, okay, I don't see any sessions of phase 1 coming up. Let me see that real quick. Is that okay? Show IP access list. First of all, no. Let me just do a show run. Oh God, this is what happens, right? Because I'm in a hurry. Section. So I'll do crypto. First of all, I'll be seeing that if there's anything missing on the crypto ACL or something. So let me just check that out. Show IP access list. It only has one. Coming from this IP address, looks good to me. At least this one looks good. Let me check this guy. Show IP access list, and 20. Oh, there's the mistake. There's the mistake. As you can see, I specified 100, when in reality, it's basically .200. So mistake over there. So that is, I just love troubleshooting, man. I mean, it's really interesting actually. If this happens in a live environment, you get to love it if you know the basics. You need to know the basics. Remember that. People always ask me, how do you do this much troubleshooting and how do you know where to pinpoint stuff? The thing is, if you know the basics right, you will always do a good job in troubleshooting. So enough of my oh, I don't want to say the word. So 200. So there it is. Show IP access list. There it is. And we have to ping it again, and let's see if it works. Yeah, bingo, it's working. So now let's check the NAT ACLs, the NAT statement, sorry, show IP NAT translations. So as you can see, the translation is being happening. No, it's not. Oh yeah, it is. There it is, as you can see over there. So let's just do a telnet now. Do a telnet to 10.1.10.100 and see what we have. Admin Cisco, because we have the same script. And this is bank server number 1. So let's check our internet connection. As you can see, the foreign address that it sees is 172.16.1.100. This is what the bank wanted. And if we log out from here and we go to the other server, which was telnet that to 10.1.20. What was it? 200. So if I do that, it's admin Cisco, and do a check of the connection, as you can see, it is also coming from this IP address. Now, one thing which we really needed to check is that, does the NAT happen when I try to access something else over the internet, like this IP address over here? Now, the problem with that is I don't have any NAT overload statement configured, so chances are it's gonna come here and be dropped. So what I'm gonna be doing is I'm gonna do open a Wireshark capture here on gig 0/0 and show you the ICMP pings coming up, and you can see that it has not been netted because the condition is present there. I hope so that this works. I'm just doing this on the fly. I should have actually configured the condition, but I didn't. Let's test this out, man. It's gonna be interesting. So I'm gonna do a ping 80.1.1.2, and it's not gonna work, obviously, but there it is. As you can see, ping packets are coming in directly from the NAT router, and this is actually what happens if you don't have NAT configured on your side. They're gonna come to the ISP, and the ISP is just gonna drop them, because RFC 1918 are actually routable IP addresses, but the ISPs have these ACLs or filters on their interfaces facing inwards, that if any RFC 1918 IP addresses show up, they're gonna drop that, because that's gonna conflict with their network and with the networks of other ones. That is the reason we're using this kind of a conditional NAT, because we can't actually use our same IP address with those guys, because they have the privilege of using that RFC 1918 address in their organization. So everyone has their own free will when it comes to RFC 1918. So this was conditional NAT. I hope that you have understood this topic, and this was a practical approach. I had to actually give you this practical approach, because without it, it won't be very useful to you, because I haven't really seen conditional NAT being used that much in the industry, and this was the condition that actually was rememberable for me. Well, I hope this has been informative for you, and I'd like to thank you for viewing.